All right, let's look at lesson 8. So here we're talking about, once again, scale drawings and maps. This time we're more using the unit rate and with speed to try and figure out time it would take to travel or distances. So this first part right here, it just says two cities are 243 miles apart. It takes a train 4 hours to travel between the two cities at a constant speed. Okay, and it says a car traveling between the two cities at a constant speed of 65 miles per hour. Which is traveling faster, the car or the train? Be prepared to explain your reasoning. Well, we're given the speed of the car, so we have to find the speed of the train. We know it goes 243 miles in 4 hours. So what we have to do here is we have to divide. So divide our distance by our hours. And then what this will give us, our answer will be miles per hour. So 4 can go into 24 6 times. This would be 0. You bring down the 3. 4 cannot go into 3, so that'd be 0. And then you're left with 3 as a remainder, so that becomes 3/4, 3 over 4. So the train is going almost 61 miles per hour. Well, 65 is faster than 60 and 3/4. Therefore, the car is going faster. All right. This next one says you're driving on I-90. A driver is traveling at a constant speed on the Interstate 90 outside Chicago. If she travels from point A to point B in 8 minutes, did she obey the speed limit of 55 miles per hour? Explain your reasoning. Okay, you'll see this map here. I'm going to jump over real quick to the interactive that students who will be at home will see. Otherwise, you would measure this out. You're going to measure the distance from A to B. And you have the scale to use right here. So we're going to apply that to see how far it is. And then we can find out how many miles. And and we divide that by our 8 minutes. So I'm just going to jump over real quick. Okay, so here we've got the same map. This just gives me some tools I can use to make some quick measurements. Once again, just because I don't, this is on a screen, you can't see me actually measure, but this will give me a quick dimensions here. So that's 13.7, that's 3.2. So altogether they're traveling and we could say that it's just about 17. So 17 centimeters. Now, to find out what a centimeter represents, okay. So I'm going to say that's actually going to correlate to about 4 centimeters. There, I like that. Looks a little better. Okay, so 4 centimeters equals 2 miles. All right. So we've measured it. We know the distance now. We have to use this 4 to find out how many miles are actually from A to B. Okay, so we know it's 17 miles from A to B. And we know that, or sorry, not 17 miles, 17 centimeters from A to B. And we know that 2 miles equals 4 centimeters. So we're going to divide this by 4 to find out how many miles is between A and B. So 4 can go into 17. That'd be 4 times. That'd give us 16. And then this would leave us with 1. And so our remainder of 4 and a quarter. So that's how many 4 centimeter segments go into that. So that would be 4 1/4 times 2. That's going to give us our total miles. So 2 times 4 1/4. 2 times 4 is 8. 2 times a quarter is going to be 0.5. So there was 8.5 miles from A to B. Okay, so now that we know the miles, we also know the time. So to find the miles per hour she was averaging, we're going to take the miles and divide by our time. However, speed is in miles per hour, not miles per minute. So we're told that it takes 8 minutes for her to go 8.5 miles. Or actually, I'm going to set up a little bit different. Miles over 8 minutes. But we're going to have to multiply this by the ratio of minutes to hours. So there's 60 minutes in 1 hour. Okay, so we do this. This is going to cancel out our minutes and give us the exact time it takes miles per hour. Okay, well, 8.5 divided by 8 is going to be roughly, well, it's going to be 1, and that would be 5/8. Nope. And 1/16. Okay. That's roughly 1 point. A 16th would be 12. I'm just going to say 1.7. That will give us close enough. So 1.7 is what we get when we take the miles divided by minutes. So she was going about 1.7 miles per minute. Okay, so now we have to multiply that by 60 to see how fast she was going per hour. So that times 60. Oops, and once again, that is not 1.7. That's 1.07. Sorry, 1/16 is 0.0, is almost 0.07. Okay, so when we multiply those together, you're going to get 60 miles, roughly about 60 miles per hour. Okay, so obviously the speed limit was 55. She is clearly going over 55 miles per hour. So to answer the first question, up here, she does not obey the speed limit, because to go that distance in that amount of time, she had to be traveling an average speed of 60 miles per hour. Okay, so the second one says a traffic helicopter flew from point A to point B in minutes. Did the helicopter travel faster or slower than the driver? Explain your reasoning explain or show your reasoning. Okay, now to think, a helicopter is not going to follow the road, right? The straightest or the quickest distance from A to B is a straight line. So the helicopter is going to take this path. So we're going to follow the same steps we just did, but we need to find that distance from A to B. So come back here. So we're going to get a line. Okay, so that's 16.2. All right, so we're going to do the same thing. We're going to divide by, so we know this is 16.2. So now we have to do the same thing. We're going to have to divide that 16.2 by our 4. So once again, this would be miles. No, this is centimeters. Sorry, we're not there yet. Okay, so if we're going to go to 16.2, that's roughly 4 times. And then that would be 0.04. 5. Okay, so that's the distance they travel is 4.05 miles. Oh, sorry, no. And each one of those represents 2 miles. That's right. So then you have to multiply this by 2 to get our full amount of miles that distance is. So 4 times 2, that's going to come out roughly at 8 miles. Okay, so now that we have that, we're going to see that if you set everything up the same, we divide by 8 minutes, because once again, it took 8 minutes to get from A to B. It was a shorter distance, and it took them the same amount of time. As you go through the same thing, 8 divided by 8, going to times that by 60 minutes over 1 hour. These cancel out, leaving us with roughly 60 miles per hour. Okay, so a traffic helicopter flew directly from point A. Did the helicopter travel faster or slower than the driver? It traveled a little slower, but not enough that we're going to really notice much of a difference. This is a 16th times 60, so that was a half a mile longer. This one was not, or this one was a half mile shorter. So I'd say they're roughly the same. The helicopter did fly a little bit slower, but it's not going to be that noticeable. All right, the last one, biking through Kansas. So it says a cyclist rides at a constant speed of 15 miles per hour. At this speed, about how long will it take the cyclist to ride from Garden City to Dodge City, Kansas? Okay, so once again, you have your scale here. You measure this out. And when you measure it, you're going to find that it's roughly about 50 miles. That is the distance from Garden City to Dodge City. And just with a ruler, that's good enough, about 50 miles. With all the turns, and if you don't get everything exact, when you're adding up your centimeters, we're going to call this good. And when you measure that, you'll get the ratio to divide by, so just like what we did up here, 2 centimeters was equal to 4. Or no, sorry, 2 miles is equal to 4 centimeters. And this one, depending on what that measures, looking at it, I'm going to say it's probably about 1 centimeter is equal to 4 miles. And so once we measure this out, it comes out to be about 50 miles in distance. So now our question is, how long, or at a 50 mile speed, how long will it take the cyclist to ride from Garden City to Dodge City? Well, if he's going 15 miles per hour and it's 50 miles, we just have to divide 50 by our speed. Okay, 15 can go into 50 3 times. That's going to give us 45. That's going to leave us with 5. So it's 3 miles and 5/15, which is equal to 3 1/3. So it's going to take him 3 1/3 hour. Well, to be more precise, 1/3 of an hour is 1/3 of 60. So 60 divided by 3 is going to equal 20. So the total time it's going to take is going to be 3 hours and 20 minutes. That should be hours. and that's not 3 hands. 3 hours and 20 minutes. Okay, so that one, whenever you're given a distance and a speed, you're going to divide them to find your time. Because remember it's miles per hour. So when you do the division, you get rid of the miles and you're left with just the time. And we'll cover that a little bit later in the next couple lessons. All right, so it just says right here, are you ready for more? Jade finds a map that says, no, this map is not to scale. What do you think this means? Why is this information important? Well, if a map's not to scale, right, we know that even if we measure it, it's not an accurate distance for us to use. So no matter what our speed is, we can't really find out the actual time it takes to get there. And we can't use it as an, okay, well, we know we take a right turn in so many feet or whatever, because it's not to scale. You just have to, it's just less accurate and it doesn't give you the information like a scale drawn map does. Okay, last thing, this is just the cool down, kind of just to make sure everybody understands what's going on. It says here's a map of the Missouri Botanical Garden. Claire walked all the way around the garden. Okay, it says, what is the actual distance around the garden? Show your reasoning. Right, so once again, we're given this scale right here. We know that that distance from there to there is 600 feet. This is going to correlate to roughly and now this is on my computer, so depending on what my screen is, I'm just going to set that equal to 2 centimeters. So for yours, if you have the paper copy, it's going to be a little different. Okay, so now that's 2 centimeters. So 2 centimeters equals 600 feet. So now I can measure how many 2 centimeters there are. So this is roughly 4.7 centimeters. And once again, if you have the printed copy, your numbers might be a little bit different, but it should all come out to be about the same. Okay, that's 9.5. This is 2.9. This is about 3.5 to where it makes this jog here. From there, that's about 5.8. And that last little part is just 1 centimeter. Okay, so it asks us to find the actual distance. So now we're just going to add all these up. That's how many centimeters. And then for every 2 centimeters, it's 600 feet. Or this 300 is halfway, so that'd be 1 centimeter. So we can multiply our total distance, or our parameter, by 300. So when we add them up, you get 2.9 plus 9.5. That's going to give us 12.4 plus 1. 5.8, 3.5, 4.7. Okay, 7 plus 5 plus 8 plus 4. And that's going to give us 24. Carry the 2. 2 plus 2 is 4, 5, 10, 13, 17. So now we have 27.4 centimeters. So by noting that half of 2 is 1 centimeter, and that correlates to 300 feet, it just saves us the time from dividing by 2 and then multiplying by 600. So here all I'm going to do is multiply this by 3, and then I'll add in then I'll move the decimal 2 to the right to represent the 300. So 3 times 4, that's 12. Carry the 1. 3 times 7 is 21. So that'd be 22. And then 3 times 2 is 6, plus the 2, 7, 8. So that would be 8220. Okay, so I just moved the decimal over 2 to represent the 2 zeros that you don't see me multiplying by here. Okay, so the total distance would be 8,224 feet. So that's the total distance around. Okay, and then the last part, it says it took Claire 30 minutes to walk around the garden at a certain speed. At what speed was she walking? Okay, so now we know the feet. We know the time it takes, so it's just 82. It's just our distance divided by our time. I believe it was 30 minutes. Yep, so 30 can go into 82 twice. That's going to be 60. That's going to leave us with 22. We now bring down the 2. 30 can go into 222. That would be 7 times. That would give us 210, leaving us with 12. Bring down the 0. So now it is 120. 30 can go into that 4 times. That's going to even it out. So Claire is walking at a speed of 274 feet per minute. And this is good enough. We could do feet per hour, but this is going to give us just what we need to know. So 274 feet in 1 minute. All right, and that's the scale drawings and maps and how we can use speed or our rate of speed or find our rate of speed to answer